Okay, hello everyone. My name is Ferdinand Reddy and I want to presentation. Uh, my PPT is and the topic is about steel product and properties. And my presentation is from book source is the Metallurgy for the non-metallurgy second edition, edited by Arthur Sheridan. And the content is 8.1 is classification of steel, 8.2 is carbon steels, 8.3 is alloy steels, 8.4 is alloying element in steel, and 8.5 is strength and toughness. And the first is 8.1 is classification of steels. You can see the picture in 8.1 is a classification of steel in the from ferrous alloys, and in the end is a duplex structure and so many about the classification. And the steel from one of the most complex group of alloys in common use, and there are many ways to classify steels. Classification of steel based on chemical composition is a widely used method. There are the three very broad base categories of steel based on composition in the picture point 8.1 is a plain carbon steels, low alloy steel, and high alloy steel, which includes stainless steel. Steel making can be broadly classified into two steps. In the first is primary steel making in a converter of furnace, and secondary is steel making in a ladle. Ordinary grades of steel may bypass the secondary steelmaking process. The two most important steelmaking processes are the electric arc furnace or EAF, or and the process and the basic oxygen furnace is a BOF, and the process or LD Linz-Donowitz process. The EAF is a process account for 35 to 40% of the world steel production, and BOF is produce 50, sorry, 55 to 60% of steel. In solidification method is after steel is melted and refined, it is then solidified into useful form by various casting methods. On a tonic basis, most steel is now solidified in continuous casting operation, but casting of steel still involves the original method of solidifying into the ingots. The molten steel is transferred from the steelmaking vessel to a refractory line ladle, from which it is timid into a container called into molds for solidification heat treatment. One of the primary advantages of steel is their ability to achieve high strength through heat treatment while still retaining some degree of ductility. Heat treatment can be used to not only harden steel but also to provide other useful combination of property, such as ductility, formability, and machinability. And the second is 8.1 is a carbon steels. You can see the table 8.3 is composition of selected carbon steel in the UNSSRA system. In this table, you can see the so many number of a table, and the picture 8.3 is a spark pattern to identity low and high carbon steels. A spark from 1015 steels. And the picture of 8.4 is a variation of in average mechanical properties of as roll 25 millimeter in the 1 in diameter bars of plain carbon steels as a function of carbon content. In the 8.3 is alloy steel contain magnesium, silicon or coppers in quantities greater than those for the carbon steels, or they have specific range or minimum for one or more of the other alloying elements such as nickel, chromium, molybdenum, and so forth. Sometimes alloy steel are further defined as being either low alloy steel or high alloy steel. Depending on the weather, total alloying content is less than 8% in the picture 8.4 and the picture 8.4. This is not a hard and fast rule because some steel with alloying simply above 8% are sometimes referred to as medium alloy steel. High alloy steels typically prefer to stainless steel, marine steel, austenity steel, magnet steel, and some ultra-high strength nickel steel. You can see the picture table 8.4 is the types of low alloy steel in the SIA and the IEC system of the designation. In the picture 8.5 is a general comparison of CarPV notch thickness for a mild carbon steel in the STM R7 and now STM R283 grade D and highest LR steel and heat treated constructional alloy steel. You can see the 8.4 is alloying elements in steel. Steel from one of the most complex groups of alloys in common use. The, signal, the synergistic effect of alloying elements and heat treatment produce of tremendous variety of microstructure and properties. Carbon is the single most important alloying element in steel. It is the principal hardening element and it is essential to the formation of cemented if I3C and other cabbage, perlite, spheroidite, in the undergrads of spherical cabbage in the spheroid matrix, bayonets, and iron carbon martensite. The relative amount and distribution of these individual pests can be manipulated through heat treatment to alter the microstructure and therefore the properties of a particular piece of steel. Manganese is a normal present is in all commercial steel. It is important in the manufacture of steel because it deoxidize the melts and facilitates for working of the steel by reduce the susceptibility to hot shortness. 8.4 is alloying element in steel. In the first is in the third is silicon is one of the principal dioxide used in steel making. The amount of this element in the steel width is not always not in the chemical composition specification. Depends on the oxidation process specified for the product. Remote and capped steel contains minimal silicon, usually less than 0.05%. Fully killed steel usual content is of 0.15 to 0.13% silicon for deoxidation. If other deoxidation are used, the amount of silicon in the steel may be reduced. Silicon has only a slightly tendency to segregate. Hydrogen is an unwelcome alloy addition to any steel. It can be dissolved in steel during the melting and casting process through contaminated scrap or through water vapor and can variously embrittle it. This effect is not the same as the embrittlement that results from electroplating or pickling. The presence of hydrogen can result in surface cracks or flake formation as the steel cools from hot rolling temperature. In the 5.5 is the strength and toughness. You can see the picture and the picture 8.12 is a stress to produce crisp character in 100 hours for various alloy. And this is a stress MPa, the aluminum and its alloy, magnesium alloys, and austenitic stainless steel, work nickel based alloy, tungsten, and niobium alloys, and etc. And the table 8.6 is a general comparison of mild low carbon steel with various high strength steel. You can see the steel of the many steel in the low carbon steel. And coins are tempered low alloy steel. Okay, that's all my presentation. Thank you.